Hello everyone. Yeah, welcome to the session. My name is Jiten Palaparthi. I think you can see my LinkedIn profile on the screen. So today's session, I'm going to explain about Rust static dispatch, and there will be a following video which I will discuss about dynamic dispatch. Okay, let's get started. So we are all well aware of polymorphism. We have been doing programming for some time. I hope all of you are doing programming for some time. You are well aware of polymorphism. So this is what the left side image, if you see, speak is a function. For example, if you think speak is a function or a method, the way how three different animals speak is different. Three different implementations. That is what exactly the polymorphism is. It's a fundamental principle in object oriented programming languages. What happens is, because of that, the objects of different types can implement that particular functionality, in this instance speak, in a different way. That means the name of the function is same, but the implementation is different. Sometimes the signature also changes. Maybe speak with the parameter, speak with the two parameters, speak with the return type. That is also called as polymorphism. But polymorphism varies based on the programming language. Okay. In general, object-oriented programming language, we use polymorphism, generally writing functions with the different signatures but with the same name in the same class, or functions or virtual functions which can be overwritten in their derived classes, or we can create some interfaces and then we can define functions or methods in interfaces and then we can implement them, that whichever the type would like to implement that particular interface. Basically, in object-oriented programming language, that is how we achieve polymorphism. But this particular session is specially talking about uh, Rust programming language. Rust is not a programming language that has got inheritance. Inheritance. There is a base class, and then there are classes that are derived from the base class. Whether it is multiple inheritance or multi-level inheritance, Rust does not support. Not only Rust, even the latest programming language Go also uh, doesn't support type-based inheritance. But how can you achieve polymorphism if there is no inheritance? How can you achieve polymorphism if the same method name cannot be used in the same type? Because Rust has got structs. Rust doesn't have classes. Rust has got structs. The methods that we are going to attach to a type by implementing those methods. Okay, we implement methods for a type. That is what we attach methods to a type in Rust programming language. So how do you achieve polymorphism? Whether it is a static dispatch or a dynamic dispatch. That means polymorphism at compile time or polymorphism at runtime. How do you achieve this? We can achieve this by embracing traits. Okay, this is traits are the methods that Rust uses. Traits are the type that Rust uses in order to achieve polymorphism. That we also call it as a static dispatch. That means static dispatch happens at compile time. Whenever you compile your application in Rust, particularly, okay, compiler is well aware of which method is called from which type. So what is the object that or what is the object that is calling this particular method, and then that particular method is invoked, which we call it as a static dispatch. That means everything happens at compile time. The decision is taken at compile time, which we call it as a static dispatch. So whatever I said, static dispatch and Rust mechanism where the compiler determines which function or method to call at compile time. Okay, as opposed to runtime. It doesn't mean that in Rust we cannot call it as runtime. We can also call it at runtime, but that is not called as static dispatch. That is called as a dynamic dispatch. So what happened is Rust has got a very strong preprocessor. Okay, the compiler is pretty strong. Okay, Rust has got macros. Rust has got a very strong optimization techniques uh, or code generation techniques by the compiler. The compiler generates a lot of code for us. Mm. So how does the static dispatch happens in Rust? Static dispatch happens in two ways. Okay, directly you can call an object of a trait that could be static or dynamic dispatch. That depends on. I will show you through an example. Or the other thing is through generics. Generics, we know that, generics means we know that the objects, the types that whatever we pass, if you want to implement a method with a generic, then any type that satisfies the generic is is a legitimate type in order to pass as a parameter or a type of a generic or a parameter wherever you are passing a generic. However, we are aware of the generics. What happens whenever you use generics? Generally, static dispatch happens either through generics or through, and another concept is using traits also you can do, or monomorphization. Okay, generics are very straightforward method. Monomorphization means Rust. What it does is, of course, whenever you are calling generics, whenever you call a generics as a parameter, Rust uses to convert the generic code into a specific code for each concrete type that is used. That means you are not aware of that. You have written a method with a generic parameter or a generic return type. That means you are telling the compiler, hey, I'm going to accept a parameter which is a generic. I'm going to return a return type which is a generic. But the compiler should know, or compiler knows, that whenever you are trying to compile your code, the compiler is well aware of that what exactly object that you pass. So it generates a code specific to that particular object. Okay, nothing happens in the air. Okay, everything is for everything, whatever we are doing, particularly the concept of generics, the concepts of interfaces or traits in Rust. There is a cost. There is a cost. There is a overhead. There is a overhead. That overhead happens either at compile time or at a runtime. The runtime overhead we will discuss it later. Okay, this is what actually the static dispatch is. Let's go to an example of static dispatch. Okay, cargo new. Static dispatch. I create a new cargo project with a static dispatch. What I do, I go to training. I have, I think Rust tutorial. I have the static dispatch. Just now I have created. What I do here is first I create a trait. Trait means, as I said, as interface. I shape is the name of the trait. I write function area, and then I'm going to call it on a object. It's going to return float 32. I'm going to return perimeter. Again, it is going to be called on an object. So if it is of 32. Now I create a type, rectangle, length f32, and breadth f32. Now I would like to implement that method. IMPL iShape for rect. That means I'm trying to implement iShape for rect, the area, and then perimeters. I'm expecting that you have basic knowledge of Rust. If not, I will create more videos on that. But this particular session is specially designed for static dispatch and dynamic dispatch. So sorry, self.l, because we have to return, and self.b. That's how the area is, and then return self dot 2 into, I put it as 2.0 into self.l plus self.b. We have got area and perimeter of rect. This is the rect, and then we are implementing that in trait for rect. Let me create another thing called square. I create it as a unit. I create it as a unit struct as a square, and then I implement this particular thing for square. So area and perimeter are same, but here square self dot zero into self dot zero. You know that what self dot zero and self dot zero, that is how actually we have self dot zero, uh, I think 4 into self dot zero. This is the perimeter. So we have created two objects, two types, sorry. One is called struct of rect, another one is called struct of square. Now, what I would like to do here is I would like to implement over here a simple function, okay, print area and perimeter. And then for that particular function, I give it as I shape. I'm going to create a generic and then t as t. To see this, I'm going to call it as a, this is a generic type, this particular type. So what is the generic type? This generic type is telling that anything that any object, any type you can pass, any object of the type you can pass, but the caveat is the rule is that it has to be implement I shape. Okay, just now what I do print line area. So what I do t dot area and print line for simplicity t dot perimeter, print line macro t dot perimeter. Now what I do here is I create an object called r1. Let r1 equal to rect of, we have area 4.45 and then we have breadth maybe 13.56, and then let I create a square object equal to square of maybe 24.5. This is units struct. Now I call the function called print.area, where I'm going to call r1, and then I'm going to call again print.perimeter. I'm going to call as s1. I can call r1 and s1. The reason is here we have the parameter that we have to pass is a type t. Type t is nothing but I shape. Okay, this is how I can, if some people they also write something like instead of this, I think you can also write fn print area and perimeter one, for example. You can also write like this, uh, t, where t is t, and then they write where t is I shape. Like this also you can write. Yeah. Both of them are both you can either declare like this and write like this, because some implementation they call lot and lot of lot of many traits are used, so they can keep on writing and plus, and then you can write that. It's more clean code than this. Otherwise, the code keep on growing like this. This method, if you write a lot of types over here, so this method will become very big. That is the reason some people write like this. However, this is what actually static dispatch. We call it as, this is a static dispatch. Okay, cargo run. If you run the cargo, you see that the area of rect is printed and then the area of square is also printed. How do you know that it is a static dispatch? Generally, static dispatch happens. One thing, how it is implemented, it is decided at runtime. It is decided behind the scene. You don't see it. Basically, here you are calling a generic type. Whenever you use a generic type, it is a static dispatch. There is another way to implement a static dispatch even with a trait object. Okay, I can create the same method here without using generics. What I do here is I remove this part. What you can do is IMPL. There is a special keyword for IMPL. You can use IMPL keyword. Okay, IMPL is a keyword. IMPL is a keyword that is used to call the, that is used actually a trait. type as a parameter. This T is a trait object. Remember that T is a trait object. I insist once again. I repeat, T is a trait object. You can also implement like this. Okay, there are three types anyway you can implement, but these are all static dispatch. I tell you, I repeat why these are all static dispatch. The compiler decides when you compile your code itself. The compiler decides, hey, I'm calling a object called R1, which is an object of the rate. I'm calling the object as R1. Uh, I'm again calling an object called S1, which is also type of the trait. So this is how actually it tells that this is using a static dispatch. So behind the scene, whatever happens, you don't need to know, but what you need to know is static dispatch happens at compile time. The compiler will decide. For example, you want to know Rust C emit LLVM IR code. I'm compiling with the output of LLVM IR src main.rs. You see that some LL code is generated. So if you really read this LL code, how do you one way straight away way is definitely unless you know that LL code you cannot understand what this is doing. But what you can do is this V tables other than V table.0. If you find more V tables here there is only one V table which is called V table.0. You can see that there are only two. Only one vtable is generated for other purpose, but generally more than one vtable is not called. You can 100% say that it is a static dispatch. But you want to do more about it, then you can always call this rust c llvm.rs to see actually what llvm ir code is getting generated. Okay, this is what about static dispatch. We will come back. I will explain the next session about the dynamic dispatching another session. Thank you very much.